Okay, so question circle theorems, because you've got circle with shapes within them with angles, and it's a starred question. So in other words, you've got to give reasons for every step you take. Now, my advice is if you write the reasons around the picture itself, the examiners have to look where you have done any work within the box of the question, and they've got to give you the credit wherever it's been written. So personally, rather than write out all the fancy language, A, B, C equals blah, 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 and the rest of it, I just do arrows to the picture, and it helps me to get the marks. So what can we see within this picture? Well, we can see a four-sided shape that has all the vertices of the circumference, so that's a cyclic quadrilateral. We can see that there's an arrowhead kite in here, going from C to O to A. So it looks like we're going to be using the theory of cyclic quadrilaterals and the arrowhead kite. That's two of the common circle theorems that you need to learn and use. So let's have a look. Without even thinking about the question, let's add on information. You know, as soon as we can add on information to a picture, we should do, and then it might be useful later on when we're actually answering the question. So because I know that the angle at the centre is twice the angle at circumference for angle subtended from the same arc CA, then if that's 168, half of that is 84. So I can fill in that straight away. I know this is a cyclic quadrilateral going around the outside there, and opposite angles in a cyclic quadrilateral add up to 180. So if that's 84, then this must be 96 degrees. So I can write those on without reading the question, so I've got some information to maybe work with to get the rest of the question done. Let's have a look what the question actually wants. So points of circumference, yeah, just confirm it's a cyclic quadrilateral, telling us that angle. Work out the size of angle ADC. So let's look where ADC is. ADC. Well, we've actually done it. So ADC has already been worked out by just putting on facts that we knew from the picture itself before we started doing the question. So let's give the reasons then, because we know what we thought about. So we can just do an arrow there, and we can say angle at the circumference is half the angle at the centre when subtended from the same arc AC. Okay, so both of those angles, that angle there came from A and C, and that angle there came from A and C. So that's that reason there. And then we realise we've got a cyclic quadrilateral, and the opposite angles in the cyclic quadrilateral add up to 180 degrees. So all we've got to say here is opposite angles in a cyclic quadrilateral add up to 180 degrees. So we've just got to finish off showing our sums then. So we did 168 degrees halved, so that's why we end up with 84 degrees there. And here we did 180 degrees, take away 84 degrees, which gave us 96 degrees. So that's that question done. We've looked at the pictures, we've broken it down into shapes that we can see to use some of the circle theorems we know. We've written the reasons down, and we've explained our workings through the sums we've done. So there's enough there to get all 4 marks. So 96 degrees on the answer line. Job done.